probability distribution. Now I want us to continue and look at how we can determine the sample size for a given margin of error. If we know what the margin of error for a selected scenario is, then we can choose how many samples we need to provide a specific confidence level. Our sample size formula and therefore follows this scenario. Now, we only perform this when we know what the population standard deviation is. And so our sample size n is equal to the z alpha over 2 value multiplied by the population standard deviation divided by the margin of error. And once we are able to calculate that, we always have to square it. Let's look at an example of a scenario where we can calculate the sample size. So Discount Sounds is evaluating a potential location for a new retail outlet, just like we did in the first case, based in part on the mean annual income of the individuals in the marketing area of the new location. Let us see how we can determine the sample size. Suppose that Discount Sounds management team wants an estimate of the population means such that there is a 0.95, which is 95% confidence level, that the sampling error is 500 or less. How large should the sample size be to meet the required precision of standard deviation of the population equal to 4,500? And so here, what we are looking at is determining the sample size if we have a value of our margin of error. Again, our formula said our sample size n is equal to our z alpha over 2 value multiplied by the population standard deviation over the margin of error, all squared. We know our margin of error to be 500, our population standard deviation is 4,500, and our confidence level is 0.95. So knowing our confidence level to be 0.95, we can actually substitute the values in. For 95%, our z alpha over 2 value will be 1.96. At a population standard deviation of 4,500, we will rearrange the margin of error formula to find the sample size, and that should be 311.17. Take a closer look. The sample size calculated is 311.17. We do not have a 17 person, so we always have to run up to 312. Very important. We don't run down. When it comes to sample size calculation, we always want to go up. Why? Because we want large sample sizes. And so sample sizes, even when you get a decimal value, should always be rounded up to the whole number in the ceiling. We always run it up and not down. We go up to a higher value of 312 instead of 311.70, which means to reach a desired margin of error of $500 at 95 confidence level, we need a sample size of 312. I would like you to spend some time and work on this practice question. We will discuss it in class when we meet. So the last thing I want to touch on before we close the chapter on this discussion here is to look at how we will estimate for population proportion. We've looked at confidence interval estimate for Z distribution. We've looked at confidence interval estimate for T distribution. We are going to end with proportional distribution. Now, looking at proportional distribution, we are looking at applying the central limit theorem. And so approximating a proportional distribution as a normal distribution, our confidence interval is going to be R sample proportion plus or minus the margin of error. It's the same as what we've been doing so far. For Z distribution, is a sample average plus or minus the margin of error. For T distribution, is a sample average plus or minus the margin of error. For proportional distribution, it's going to be the sample proportion plus or minus the margin of error. But how will the margin of error be in a case like this? Assuming our sample size is so large that when we multiply the sample size and the probability of success is going to give us greater than 5, and the sample size times the probability of failure is also going to give us a value greater than 5, our margin of error is going to look at this as our standard deviation of the sample proportion. So our margin of error formula will therefore be our sample proportion plus or minus the margin of error. The margin of error is still our Z alpha over 2 times the standard deviation of the sample proportion. Let's take a look at an example and see how we can calculate the confidence interval for a proportional distribution. In a current election campaign, PSI Company Analytics online survey observed that 220 registered voters out of 500 contacted favor a particular candidate. PSI wants to develop a 95% confidence interval estimate for the proportion of the population of registered voters that favor their candidate. What will you suggest the confidence interval as? And so here we're looking at finding our confidence interval, but it's for a proportional distribution. Our confidence interval formula says take your sample proportion, which is p hat, add and subtract your margin of error, which is your Z alpha over 2, multiplied by the standard deviation of the sample proportion. Our sample proportion p hat is calculated by dividing x over n. X is the 220 registered voters out of the 500 who said they will favor a certain candidate. And so in our calculation here, we are going to divide our x of 220 by 500, which will give us a sample proportion of 0.44. Our standard deviation, our margin of error will consider the Z alpha over 2, which is 1.96, times our sample proportion of 0.44 times 1 minus 4.44 over 500. So in this case, our margin of error here will be equal to 0.0435. We will add and subtract it from our sample proportion, and that should give us our confidence interval. Using this, we will estimate that at 95% confidence level, we hope to see the proportion of those who will favor that candidate to be between 0.3965 and 0.4835, which means at 95%, we expect to see 39.65% to 48.35% favoring this particular candidate. And so this brings us to the end of our discussion. We've looked at confidence interval estimate for Z probability distributions, T probability distributions, and proportional distributions. These three are very important for the purpose of your final exams. And so I will encourage you to go over it, show up during the lecture discussions, and let's practice more on this. Thank you and see you in the next video.